simplify the problem. So in this case, it's the most complicated one. Next one, show this. The seek time first is when you add up this, you can add up from to here, then from to here, from to here, then that's it. So what is the show this the seek time? Because the first compressor will use the order of arrival time to the queue, so it's definitely not optimized. So if we can visit the nearest one first, then that will be optimized. So that's the idea of the show this the seek time first algorithm. So it looks like the show this job first in CPU scaling algorithm. So why don't we process the show this amount of the CPU burst time process first? So similarly, why don't we access the data in the nearest cylinder? Okay, that is the idea. Which one is the closest one? From the current head position is 53, so that is the 65. Even though 65 arrived lately, but it will be read by the disk header first. Then from 65, which one is the nearest one? 67. From the 67, which one is the 37? And from 37, 14, and next. So that is the show this the seek time first. When I calculate again, when I get back to home yesterday, it's a 236. Probably I missed it somewhere. Okay, that is the show this the seek time first. The next algorithm is the scan, just like the elevator. So sometimes you may feel unfair to ride the elevator. Okay, so the simplest way is just going up and down, up and down. Okay, so that is the same idea in the scan. So why don't we move forward and backward on the way of moving? If there is any request among the queue, then read the data. Okay, that's the idea. So then this time, even though we do not have the data in 0, but we will touch y because this is a steady case. What if the real life the situation? There might be incoming request to read the data. Who knows? There might be another request from cylinder 0 or 1. So we can move we can let the diskette move to the edge and to the edge, to the edge, to the edge. It's like that. That is a scan algorithm. So you can add up total from 53 plus 183 at this time. Then we can get the total 200. It's a 208. I think that this one is a 236 and this is the 208, right? That's what I calculated last night. So that is a mistake. I think I changed it. I think it's a different one. So I changed it yesterday. Okay. So this is the 183 plus the 53. That is the 200. The 36. Okay. Then the show this the 6 times first is a 208. I think we need to change that. But problem of the scan is what? It's a simple to implement. Actually, it's not very simple because every time you need to know whether there is the request on the queue when you are moving. Okay, you should check every time. But here, this time you are going to check the next. So while you are moving, you don't have to check. But this one, you need to keep checking every cylinder. Keep checking whether there is the request one on the queue. But we assume we are going to consider only the moving distance as the latency. Then another problem is as we discussed before the last time, the middle part will get the higher chance, and the side part will get the lower chance. This kind of the distribution, the normal distribution. So it's not actually the uniformly distributed the possibility. So not the normal distribution. So it's not there. So not uniform. So that is a problem of the scan. So to address that problem, C-scan, why don't we move from current head to the edge, okay? Then all the way back and start to read. When you move back to the initial point, you do not read the data. Just move back and read, and move back, read, move back, read. Then total moving distance, the seek time latency is from 53 to 199, okay, plus 199 plus 37. So you need to also add this amount of time for the latency. Okay, but it's fair to any data. Okay, that is the C-scan. What about the C loop? Loop is the difference between the first loop algorithm. The scan, even though there is no data here, we assume there might be. So, but in this case, there is no incoming the request in the queue. So this is just a waste of time. Okay, you don't have to. So if there is no more data after that, then return, turn around to the other direction. And you don't have to touch the edge of the cylinder. Okay, that is a loop algorithm. So difference between the scan and loop is scan read the 0 and the maximum cylinder. But loop is just the minimum of the minimum cylinder number in the queue and maximum number of cylinder in the queue. Okay, in the queue. So that is a difference. And both sides. This is a moving forward and backward. Okay, both sides. So both direction, but not the edge of this one. That is a loop, and C-scan is a one way. Read the data, go back. Read the data, go back. Read the data, go back. And similarly, C loop is you can read the data from minimal to maximum. Okay, cylinder number in the queue, and go back. While you are moving back, you don't read. And after you read the data, if there is a new data coming in, that this point to check what is the minimum, then read. And check, read. So this is the C loop. Okay, so we have the scan loop algorithm, C loop, and the C scan algorithm. This is the example of the C loop algorithm. C loop, so it's a one way and do not touch the end, just the minimum. So read the data up to maximum cylinder number and go back to minimal cylinder number and read, and this is the end. If there is any incoming at this point, check what is the maximum and read up to the maximum. Okay. Any question? Then we can decide which one is better and the optimal. Okay, by considering the moving distance. Yes.
Does it matter which way you start?
Oh yeah, that's a good question.
From 53, do you have to go to NMR or can you go?
So right now we specify the header position is a 53. Okay. Then we don't know whether this is moving down and moving up. Okay. It depends on the previous. For example, the previous the head position is a 37. Let's say. Then this is moving upward. Okay. However, if the previous moving position is a 67, and this may start the moving downward. In case of a C loop, you need to read up to this one and do not read any data up to here, 183, and read all the data to this one. This one is read here, so it will be end to the here. Okay, so that is it depends on the where it moves. Either moving backward and forward, either downward and upward, it can be different. So sometimes I can give the direction, sometimes not. Instead, I can give the current head position and previous head position. Then you can decide the direction. Okay. However, as I said, I cannot see any recently, even though I didn't check a lot the publication. So I cannot. When I was a student, there were the even project and proposed the idea for the such optimized scheduling, disk scheduling algorithm. Especially at the time, the video is very popular at the time. So video is usually the several hundred megabyte or gigabyte. How to schedule such the big file? It was the problem. So because of that, there were specialized personal computer, like the multimedia personal computer, something like that. that use the different scheduling algorithm and different hardware. So, but nowadays, because of the technology change it, it's not very important in the hardware and solid state disk. Okay. So mostly among that, the first compressor and the shoot is the seek time first, and loop scan, see loop, see scan, shoot is the seek time is the usually, okay, natural. Everybody want to visit the nearest one first. So that may cause the starvation, okay, in case a lot of incoming data. So depending on your operating system type, you can either consider scan and the C scan. It provide the less starvation or the no starvation, okay? Okay. Any question regarding to the disk scheduling? I spend mostly a day or a week for the disk scheduling, but this time we can quickly finish the disk scheduling. Next topic is the disk management. First, when I purchased my own disk, only the disk drive, the first time, it was very hard because I need to install the device program. Because anyway, the hard disk drive at that time was not standardized. Nowadays, you don't have to worry about, but that doesn't mean there's no the device program. There exists always the device program for new device, but many of them are included in the operating system, or it can be the universal, like the USB, or it can be standardized. So that was you may not realize sometimes. But when I insert the first time the hard disk drive, I need to insert the program. This driver is provided by the floppy disk and the install. Then I need to do formatting first. What is a formatting? Formatting means it's a structure. Okay. Hard disk drive, no matter what device you have, it's just a slate. Okay. It's nothing. It's a machine. Okay. However, computer is mostly, as I suggest to you, many of my questions can be answered by structure because we are learning the data structure. So hard disk drive should be recognized by or accessed, processed by what? The operating system. And operating system can understand only the structured data. Okay? Structure the information. So we need to make something layout and organize such hardware devices. That is the formatting. So that the formatting that you can do. So even you can right click and quick format or something format. That is a logical format. What does that mean? Logical format. Is there any physical format? Yes, there is a physical format that is called the factory reset. It's a fact. When the hard disk drive is manufactured, it's nothing. It's just the slate and it's a machine itself. Then it's but the operating system can use the space as a storage after making the sector. Sector is the basic unit to that operating system can access the data. In case of a hard disk drive, so we have the disk start and it has a cylinder. Then there's a special sector like that. So each sector has mostly 512 byte size sector number, but it can be changed depending on the manufacturer. But some of the operating system limit only the 512 byte, which is popular, but it can be 1K or 2K, the bigger size the sector. Then that making the bunch of sector from your disk is called the low level format. So, for example, I have very important the private the information or the something file, I try to delete. If you know you delete the file, we will learn the next class what is the file and file system and directory, what happens when you create the file, when you delete the file. So even though you delete the file, that doesn't mean it's completely gone from your disk. Okay, so still there only logically. So information are deleted. Like if I expel him, that doesn't mean I kill him. So he is still there, but his name will be taken off from the register or the enrollment, something like that, right? So that doesn't mean that he will be gone in the world, right? He is still same thing. Even though you delete the data, so the data is still there in the sector, then logically, even though you format your hard disk drive logically, still information data are there. Okay. Then, what if I want to completely remove the data? You need to low-level format. However, you should be careful. It depends who provides such a formatting. Not operating system, you cannot do the low-level formatting. Using the operating system, only manufacturer, the company who produced this hard disk drive can do this one. Even some of the low-level formatting, they do not delete the data. Okay, so you need to the low-level formatting or low-level program. They can fill the data, like the 0000 or the special data. Then it will be removed. Okay, so that is a low-level formatting, and also. In addition to the low-level formatting, low-level format the program, the manufacturer also provides the error correction code. Because, as we discussed before, this hard disk drive can be easily crashed by scratching, something like that. But it's not fair, even though the 1 or 2 byte is scratched, the 1 terabyte data will be lost. So it's not fair. So why don't we ignore this sector? Or, so if there is the algorithm to recover this, because 1 or 2 bit or the 1 or 2 byte data, 1 bit data, it can be recovered using the parity check or some checksum. Checksum means the total, for example, sum of all the data in binary, in terms of binary, in this sector is 10. Okay? But we don't know 1 bit data. But the other, if you sum up all the other bit, it's 9. So we can just, this is 1. Something like the checksum or the parity check, that is error correction code. So error correction code cannot restore all damage the sector, bad sector. Some of them can be done. Otherwise, if we cannot restore the recover, if we cannot correct the error, then we can ignore such a sector. So that is the reason when you the power down forcefully, not gracefully shut down your computer. Sometimes the operating system, not operating system in BIOS level, it tries to check up the hard disk drive, whether there exists that sector one. Okay? So then we can make the partition from after that. All of these are logical, which means it's a data structure, algorithm, program will take care, which means operating system can take care the later part. So we can make the partition of this is a low device. But we can partition, logically this is a C partition, D partition, or in Linux it can be /DV partition or swap partition and something like that. Then we can separate. Then we can do the logical formatting per partition. Logical formatting is the formatting that you can do using the software such as the operating system. Okay? Then finally, we can use the formatted data as a storage. Okay? Who is in charge of such a partition and the logical formatting and the file management? So file system software. Okay, so we are going to discuss such a file system next to the chapter after this one. Then that will be your second project topic. You are going to implement the very simple file system. Most of the file system, commercial file system, are based on the raw device after row level formatting, so raw device. However, it will be very bit tough. You need to understand the hardware. So our all-over file system, on top of this one, there is the file system. Okay, such as the NTFS, for example, in Windows system. Then we will create the file system on top of this. Okay, that sometimes happen. For example, the big data system. Some of you guys are interested in the big data system. Big data system use the distributed file system, which is called the HDFS. That the distributed file system is not running on the raw device, but it's running on existing file system. Okay? It makes sense to use the file system on top of another file system. So in your project, you are going to implement such a. Okay. We will discuss more in the next 2 chapters. And the disk, there is one storage. So before that, what happens when you turn on your computer? First, very simple operating system, which is called BIOS. BIOS program will be running. So there's no computer without there's no way to use the computer without the operating system. So BIOS is its name implies simple, the operating system. What is the main job of the BIOS program? Checking all hardware devices. Okay, checking the hardware and checking it's kind of a firmware. Okay, it's kind of a firmware of the computer itself. Computer itself is the machine and hardware is a firmware. Then after checking all the devices, then BIOS program knows the location. Okay, location of what? Your operating system. In other words, kernel process. Then where's the BIOS program? It's in the read-only memory. So ROM. Why? Why is ROM? ROM is not volatile. Even though power up is still there, so it's still reliable. And also, it's not easy to attack. It's not easy to change, that is the limitation. Because of that, not many operator computer system use the ROM as the boot record. Okay? In other words, kernel can be, you can put the kernel in the ROM also, but it's not practical because from time to time we need to upgrade or change the kernel. So ROM instead has the information about the boot record. So then the boot code is under your partition. It is pointed by the ROM. Okay, that's how it works. So that is another issue when you manage your disk drive. Okay. MBR stands for the master boot record. It has the information about the where is the initial code, the kernel program. Then finally it will be executed. Okay, which means it will be processed. It will be first processed. Their code will be loaded into the memory. Then this initial code, the init process will create the other child processes. Okay. The next space that we are going to discuss is a swap space. What is a swap? Swap is a change. So in computer system, what is a swap operation? And do you need a swap operation? There are many, but mostly swap means swapping what? Not wives, not wife swap. I hope so sometime. Swapping process. Why do we need swapping processes. When do you need? Because what is a process? Process is a code in the memory. But memory is fast, right? That's the reason it's the primary storage. Problem? Limited size. And because it's expensive. Not only just the price, but also there might be the limitation of the add or addressing. Because the memory itself is nothing but the array of address. So there is a limitation to address. 64-bit definitely is much bigger. So because of that, right now I have the 8 GB, the memory size, even the several millions of the server, the 20 years ago, they can have the only 2 GB memory. Because of the addressing, or the 32-bit can allow the up to 4 GB hard disk drive and up to 2 GB the memory size, even though we have. So anyway, the process is in the memory is limited a long time ago when the computer is just born and they do not have enough space. Because of that, MS-DOS can keep only one process at a time. So what if the memory is full? At the time, we don't want to stop the process, terminate, because it's running. But we can back up the process. That backup space is for swap. Swap is such a backup space. So swap process by process. Problem? Your operating system will be slow. Why? Because it requires swap is usually in the hard disk drive, your disk storage, okay? Which means it requires transfer and I/O. And same thing from the swap, bring the process to the memory, it requires transfer time and I/O. So it takes a long time. However, at that time there's no other choice because we have a very limited CPU, the memory. Right now, I have the 8 GB memory size. That's my preference, but it's getting slow. I really hate such a computer stuff. It's getting slow. And even I cannot start up service. I'm not a big fan of the Microsoft, but I'm not very familiar with the MacBook because of that. I still use. But anyway, so we don't need the swap space more because we have the memory space. My memory usage is usually less than the 40-50%, never reach the 60%, which means I don't need the swap space. No, we still use the swap space. For what? As a virtual memory. It's a virtual memory. It's kind of a backup also, but still, if we add all the memory, the process memory, the size is bigger than 8 GB sometimes. Because when you read the data, for example, watching the video, it's a 2 GB size. 2 GB is loaded into the memory, so no, you cannot do that. Even though you have a lot of money, so you cannot load the entire the file to the memory. So instead, you can read the piece by piece. That is called what? Page. Because we skip the chapter 8 and 9, so that's the reason I a little bit discuss more about that. So paging, it's called the paging in, page out. Instead of swap in and out process, we can use the paging. Paging means, the swap means the entire the process. It's a memory, it's a process, one, and it's a swap space, process two. They can swap each other, okay, entire. It's a traditional way. Nobody use right now. Instead, we are going to make the page frame. It's a fixed size, the piece of memory. So page number 1, page number 2, page number 3. Then page by page, we can load this one is for process 1, process 1, process 1, process 2, process 2, process 2, process 3. Okay? Then we can load multiple the processes. Also, we don't have to load entire process whenever we need. But if this one is not, or there's no available space, we need to page out. Then this one is used for backup space. It's still same format as the memory. Looks like the memory, but it's a virtual memory. So this one swap is right now used for virtual memory. For example, Windows 10. Oops. Oh yes. So advanced setting. If you go to the advanced setting, system, hardware, device, advanced. Yes, here. So this one, it has even the virtual memory. You can see depending on operating system, it's slightly different. The Windows use the virtual memory, the swap space as a virtual memory of paging file. Okay, it's a general. The Unix, some of the Unix use multiple swap spaces, and some of the Linux system use only one swap space, but low level, it depends on. So mostly they are using the swap space as a virtual area of the memory. Instead, they need to do page in and out, page level in and out. Okay, so in this case, the paging file is an area on the hard disk drive, and Windows use this one if it were RAM. Okay, it's a virtual memory. Then you can actually change the size of them. It is kind of controversial what is the optimal size, but when I manage the operating system, based on my experience, it's usually 2 times of your physical memory. But what if I have the 8 GB memory? Do I need to allocate the 16 GB as a virtual memory? No, I don't think so, because not right now, comparing to the computer hardware specification, memory is improved a lot. So we don't need 2 times, but in this case, 1 gig. If you feel if you find any evidence there are a lot of pages in and out, okay, and it makes slower your computer, so you cannot increase the memory size. If you cannot increase the physical memory size, then why don't you try to increase this one? Okay, so this one, as a default, as the 1 GB, it can be 1.5 or 2 GB. That is the virtual memory. That is the swap space. Okay. So how can we manage the swap space? The swap space is divided by the page swap. As I said, it will be used for page. And there's another data structure that is called the SWAMnet. SWAMnet has the integer array, and each number indicates how many processes are using this one in the memory. So this page is accessed by for one process. Sometimes it's multiple, which means 3 processes use this one in case of what? Shared information, okay, shared data, shared library, for example. So this is 3 means shared the pages. I'm not going to introduce the RAID a lot, except the very specific the definition of the RAID, specific case of the RAID. The definition is R means it's redundant. Okay, when hard disk drive was very expensive. Okay, so but we want. What is the best way to make the reliable hard disk drive system, storage system? It's a mirroring, always, backup, okay? When you write the data, not just one hard disk drive, why don't we write 2 disk drive physically? Then in case one of them is failed, we can use another one. Problem? Expensive. Not right now, long time ago. So they have the very complicated algorithm to duplicate, make the redundancy, okay? So that is called a RAID 5. Some of the systems still use a RAID 5, but you don't have to worry about it. Instead, we can just mirror. Sometimes some of the, one of my friends who works for the database administrator in the bank in the United States, he said they have the 7 copies of the same data. Even they are distributed geographically. So distributed, so 7 copies. So this is not a big issue, but only RAID 0 and RAID 1 is used. RAID 1 means it's a mirrored copy, as I said. And 0 means it's a striping. Striping means distribute the data. Why do we need to distribute the data? Instead of keeping this is a HR, this is a CS, C, ME, and E. Instead, CS data will be distributed. Divide by 4 and part 1, part 2, part 3, part 4. E data, E part 1, E part 2, and something like that. Why? It can be used for parallel processing. Okay? So when we sum up the GPA, we can access the same time for CS. So then, by combining 1 and 0, or the 0 or 1, there is a RAID 0 plus 1, RAID 1 plus 0. 0, the only difference between the 0 plus 1, 1 plus 0 is which one is the first? Okay? So 0 plus 1 is the first striping, the distribute, then mirror. And the second one is the mirror, then striping. Okay, slightly different, the mechanism. Then, when you see some architecture of the IT department, you can see our disk is RAID 0 plus 1. Even sometimes they hide just a 0 plus 1. And 1 plus 0. Means the 0 means it's a striping, 1 means the mirroring. Okay. That is the RAID.
Is there one that's inherently better than the other? Is 1 plus 0 better than 0 plus 1? Or is it pretty much?
It's slightly different because first you need to, when you copy, when you access the write the data, you need to find the location. Then it will be striping. But the 1 plus 0 is it can be mirror. First write the data and mirror. Then it may be different to the location. Okay, when stripe. Okay, it may be different. So it's not exactly but this one is exactly mirror because it's after striping. But this one may be the stripe to other place. Okay. I'll just skip the. The stable storage implementation requires transaction control that will be discussed, mostly not the operating system, but it's a database problem. So I'm not going to cover the detail, but idea is, even though we make the mirroring, like we write the data, first the physical, the hard disk drive, then second physical hard disk drive, then it will be completed. The problem is, so sometimes the hard disk drive, any storage, not only hard disk drive, any storage, they do not write the data physical location. Instead, in memory only. Think about the USB. So always when you plug out your USB or flash memory drive, you need to confirm, right? Safe, removing, whatever. Why do we need such a process? Because you are writing, updating data is not applied to your hard disk, your drive. Instead, it's on the memory. We need to finalize that. Okay? That means, what if the system is down? Okay? Before write the data. Okay? So, which means it's not stable storage. So, to make the stable storage, write ahead row. Write ahead row. I'm not sure whether this is mentioned. Write ahead row is used, which means any action will be stored at the scalable storage, the physical storage, which means updated data may not be written in the hard disk drive. Instead, the update. So this is the storage N1, and this is the memory. So when you update 1 to 2, 1 to 2, but it's not the update the physical device. Then what if this one is system is down? We will lose updated data. Instead, to restore, there is a log data. So update 1 to 2. So when you start up the system, check whether this is a 1 or 2. If it's not 2, then redo. This is called the redo operation. Redo this operation, then we can make the stable storage. But it's the main problem of database or transaction control, not operating system. So that's the reason I quickly skip this part. Okay, that's the end of chapter 10. Then, as I announced, I'd like to So, October 18 is the due date of your project A, is our shell programming. So I'd like to give the chance to demonstrate your the project on October 19 during the class, in this classroom. So 11 to 12:15. But problem is, even though I can give the 5 minutes per demonstration, I can host how many? 12 to 15 maximum. Okay, so we cannot do the demonstration for all the students. So it's a voluntary. So those who want to demonstrate in the classroom, okay, they email me, not email, the Canvas message. Using the Canvas message, why don't you let me know? Okay, if the number of students is more than the 15, I'd like to host the first request, the student. Then maximum 30% extra point of your grading, the project A grading will be added to your the project A grading. So 5 minutes. So how can you prepare after you complete this one? This is the requirement of your project. So first, start compile your code. So your VM and the terminal should be ready. Then just plug in. Then show how to compile, and after compilation, if compilation is error, it's automatically next student. Okay, we cannot wait to debug. Then start your program in VOS. Then it's a prompt. Then process PS command. Okay, without any option, and the PS with the option. Okay, next one is ls the command, and ls with the option AR. Okay, then the second task is the selection command. Selection, then list of your executable file only. Then you can select one of this, 1, 2, number of them. Okay, then the executed, and also XXX should not be the executable file on your. You don't have to take the photo. I will upload. Okay. Then whether you can handle the error. Okay. Then, if you have any additional function, sure, that will be preferred. Like if you implement a byte, or if you implement the redirection, or any other functionality that you can find in general, the shell script, that will be better. And also extra point. Question. This is the only opportunity for the regular section student, not distance learning. What if you cannot demonstrate at the time? GA will set up the schedule for your demonstration also. Okay, but that you cannot get the extra point. That is for your grading purpose. And also, what if during the demonstration the Professor Lee comment and ask something, you still have the chance to resubmit. Okay, GA cannot grade right after the due date. Okay, you still have a chance to change and modify, revise. That will be a good opportunity. Any question? I'm not going to provide a laptop or computer environment. Please bring your laptop. I can support only VGA. Let me check. I have the mini, the HDMI. If you have the large HDMI, the regular HDMI only, so you need to bring the connector. And also it's a good idea to check your connector before you are doing. Also, if you do not have a laptop, but you can still use your virtual machine, then you borrow your friend, right? So because what we need is a virtual machine only. Any question? Okay, which means we have the 20 minutes more, so it's enough time to have the quiz. Okay?